On this question, we have a system of nonlinear equations. We want to sketch the graph of each equation and then determine the number of real solutions to the system. We don't want to solve the system. We're coming up with the sketch and then determining how many real solutions there are to this system. The first equation in the system is x squared minus y equals -4. And the second equation is 3x minus y equals -6. So I can tell that the first equation is going to be a parabola or a quadratic because of the squared on the x, and the second equation is a linear equation. I'm going to start with that first equation, x squared minus y equals -4. And I'm going to rewrite this as y equals, so it's easier for me to graph. I'll subtract x squared. That gives me negative y equals -x squared minus 4. And then I can divide each term by -1 to get y equals x squared plus 4. So my first equation will have a graph of x squared shifted up by 4. So I'm going to sketch that picture over here. We have a picture that looks like this. And the second equation, 3x minus y equals -6. This is a linear equation. And I can graph this using the intercepts. I have an x-intercept by letting y equal 0. That's 3x minus 0 equals -6. 3x equals -6, and I'll divide by 3. X equals -2, so I have an x-intercept at -2, 0. And for the y-intercept, I would let x equal 0. That's 3 times 0 minus y equals -6. Negative y equals -6, and I'll divide by -1. That's y equals 6. So I have a y-intercept of 0, 6. I'll plot my x-intercept at -2, 0. And my y-intercept at 6. I'm going to connect those 2 points with a straight line. If I extend this parabola a little bit further, I can answer the question about the number of real solutions in this system. The solutions to a system of equations will be ordered pairs that make each equation true. So we're looking for intersection points because those intersection points are points that will be on both lines and will satisfy or make both of those equations true. So we know that this equation or this system will have 2 solutions because we see 2 intersection points. I want to take a look at the graphing tool that we have in my math lab for this question. You can see here this is where we sketch the graphs, and you do have a quadratic tool. If you'll notice here it says 3-point quadratic tool, which means that I need to click 3 places, 3 points on the line to be able to graph this equation. So it's not enough to just know what the equation is and what the basic shape is. We need to have 3 points on this curve in order to plot it. So I can make a quick chart here of x's and y's, and I'll use -1, 0, and 1. And substitute that into our equation to get the y coordinates. I have -1 squared plus 4 would be 1 plus 4 is 5. 0 squared plus 4 is 4. and 1 squared plus 4 is 5. So this gives me 3 ordered pairs that I'll plot in order to draw that quadratic or parabola graph. I already have 2 points to draw the line, so I'll be able to draw this curve now. So selected that quadratic tool, 3-point quadratic tool, and I'm going to click on 0, 4, 1, 5, and negative 1, 5. Those were the 3 points that I found, and then it drew the rest of the pattern of the quadratic. And then I want to draw the straight line. Let me remind myself about what those ordered pairs are. Negative 2, 0, and 0, 6. Negative 2, 0, and 0, 6. And we have our 2 equations for the system. And then we want to know how many solutions are there, and you can see from this picture, just like the one we drew by hand, that there are 2 intersection points, and so that will mean there are 2 solutions. Okay. For this question, we want to determine the real solutions to the system of nonlinear equations. The system we have is y equals x squared plus 2x minus 6, and y equals x squared plus 4x equals 14. We can solve the system using either substitution or elimination. Looking at the system, I notice that my y's are lined up, my equal sign is lined up, and all of the like terms are lined up. And that is lending itself to using the elimination method. With the elimination method, we would eliminate the y, and that's because we wouldn't be able to eliminate all of the x's in this equation. Even though they're like terms, we wouldn't be able to eliminate these like terms of x squared at the same time as these like terms of x. So since there's only one y variable, we're going to choose to eliminate that. We need the coefficients to be the same with the opposite sign. Right now, they are the same. Both have a coefficient of 1. So I'm going to multiply a negative 1 onto both sides of this equation, and that would give me a new system. The first equation is remaining unchanged, and the second equation becomes negative y equals negative x squared minus 4x plus 14. And now I'll be able to add these equations together and eliminate the y term. So adding these together, I would get 0 on the left. Y minus y is 0. X squared minus x squared is 0. 2x minus 4x is negative 2x. And negative 6 plus 4 is 8. So now I have an equation with only one variable. I have 0 equals negative 2x plus 8. I'm going to subtract 8 to give me negative 2x equals negative 8. Divide both sides by negative 2, and that gives me x equals positive 4. Now my solution to this system will be an ordered pair, and we've only found the x coordinate of this. So now we need to find the y coordinate. So I'll substitute this x coordinate of 4 into x in that first equation. You could also use the second equation as well. I have y equals 4 squared plus 2 times 4 minus 6 4 squared is 16. 2 times 4 is 8. 16 minus 6 is 10. And 10 plus 8 is 18. So the ordered pair 4, 18 is the solution to this system of nonlinear equations. For this question, we want to determine the real solutions to the system of the nonlinear equations. Our system is y squared equals x squared minus 9. And negative 2y equals x plus 3. So we can solve this system using substitution or elimination. And as I'm looking at this, I can see that I have a y squared and a y. Those are not like terms. An x squared and an x, and those are not like terms. So I'm going to try the substitution method, because the elimination method requires that you be able to add the equations together and eliminate one of the variables. If your variables are not like terms, you're not going to be able to add them together to eliminate. So I'm going to try this with the substitution method. So as I look at these different variables, I notice that this one, x, doesn't have a coefficient on it. And so that's going to make this the easiest one to solve for. So I'm going to start with that second equation, negative 2y equals x plus 3, and I'll solve for x by subtracting 3 on both sides. So I have negative 2y minus 3 equals x. And now that I've solved for that variable, I want to substitute into the other equation. I'm going to substitute in for x into the other equation. And that gives me y squared equals negative 2y minus 3 squared minus, that should be a 9. And this gives me an equation with only one variable. And I want to simplify. I've got y squared. Negative 2y minus 3 is negative 2y minus 3 times negative 2y minus 3. Minus 9, we'll multiply that out. We have positive 4y squared, positive 6y, positive 6y, and a positive 9, and carrying down that minus 9. I'll combine like terms to get 4y squared plus 12y. I'm going to move all the terms to the same side. So subtract subtract y squared. And I have 0 equals 3y squared plus 12y. I want to solve this equation. I can solve it by factoring. I'll factor the greatest common factor of 3y, and then I'll be left with y plus 4. I can set each factor equal to 0 using the zero product property. And that gives me y equals 0 and y equals negative 4. So I have two ordered pairs and the y coordinates of both of these ordered pairs. And I need to find the x coordinates. So what I'm going to do is I'm going to use this equation right here since it's solved for x. I'm using the equation x equals negative 2y minus 3. And if y is equal to 0, x will equal negative 2 times 0 minus 3, and that's negative 3. So one of those ordered pairs will be negative 3, 0. Then the other one has a y equals negative 4. That's x equals negative 2 times negative 4 minus 3. That's 8 minus 3, which is 5. And so I have the other ordered pair being 5, negative 4. So I have the real solutions to this system of equations being negative 3, 0, and 5, negative 4. Thank you for checking out my videos. Have a great day.